Hello, scholars. Today we're going to look at the standard form of the quadratic equation, and we're going to look at how do we use that standard form to find particular features in the graph itself, and how do we graph it using that. We're going to use a few different tools for that. If you remember from our discussion of polynomials, a quadratic equation is really any function that has its highest degree as a second degree term. So that ax squared, that term with a being the coefficient, that term has to be there. It could have up to 3 terms. It might not. That the second term or the third term may or may not be part of the equation. It just depends on what that looks like. And remember that the shape of this of these quadratic equations are called, this U-shaped curve is called a parabola, and it has some a specific characteristic which makes it a parabola. And it happens to be that quadratic equations do make that curve that we have. So if a couple of tools that you can use for graphing is you can use a graphing calculator, or you can use Desmos, since many of you have your Chromebook out. So go ahead and let's take a look at how we would do how we would get just at least to graph a sketch of what these look like. So we're going to use Desmos. So we're going to switch up here, and we're going to create, if you go to desmos.com, you can click on the graphing calculator here. So I've pulled up Desmos, and I started typing in the equation. Again, to get the x squared, you can either use the keyboard or the Shift 6, which is the little up arrow for that. And so if we type in the rest of this equation, so that's the equation that was in our notes. And notice that Desmos gives us a few interesting features. We can certainly find the vertex. Remember, the vertex is the could be the minimum or the maximum, depending on how this parabola is created. And then we also can see what the y-intercept is. You can look at those. You can click on the x-intercepts as well. And so Desmos usually gives you a pretty nice feature to find at least some of the key features. It does not give you all the points. You certainly can, if you click on something and go to find it, you can kind of maybe get close to it, so you can find some points like that. So that's going to be a helpful feature as well. So if we wanted to sketch this, really we could we know that the graph is at -1, 6, the vertex is, and so we just and this opens up. So if we want to take a look at the other equation, let's take a look at that one as well. So I've gone ahead and typed that in. Now, a couple of things you want to remember on Desmos. You can certainly, if you don't want to look at the first one that we graphed, you could certainly unselect that, and then you can scroll in and out. If you want to look at where this is, you can click and drag it with your mouse. So again, we can find some features. So notice that our vertex here is at 1.5 and 9.25. Notice we've got a y-intercept here. We've got x-intercepts here and here. And so again, that kind of gives us that that shape. And notice that this parabola is opening down. So if you wanted to draw a sketch of that as well, you could certainly do that. And so a couple of things that we want to keep in mind. Notice that I drew that dotted line down the middle. Remember that we refer to that as the axis of symmetry because it cuts the parabola in 2 equal parts. It's a vertical line. So a couple of things to remember when it comes to the types of parabolas we see. First of all, if you notice that the first coefficient in the first one on the left, y equals x squared plus 2x minus 5, that coefficient in front of the x squared term is actually 1, positive 1. And so that positive 1 notice that actually that because that A is positive, it opens up. And you'll also notice that because the in the second equation, that one opens down, and the reason that it opens down is that the A is -1. And so since the A is negative, it opens down. And so we have some, a little rhyme there to help us remember which way they open. And again, that's the A value. That's the leading coefficient of the quadratic, which determines that for which way it opens up or down. So next, we're going to take a look just at a couple of definitions. Again, remember that axis of symmetry, we talked about that the axis of symmetry is really that vertical line that divides the parabola into two equal parts. And if we think about the quadratic equation, there's actually a formula that will help us find where that x-axis or that axis of symmetry is. It turns out that it's actually the x-coordinate as well. And so what we can use is we can use the second the coefficient of the second term, so we're going to refer to that as b. It's the opposite of that, so the opposite of whatever the coefficient is for b, and then divided by 2 times a. Okay, so sometimes we'll say that that's negative b over 2a. That probably sounds familiar in some contexts with that. Okay, so then keep in mind that that when we talk about that vertex in the first equation that we had where it opened up, that vertex was actually a minimum, and the second equation where it was the highest point, it's called a maximum. Remember that if the parabola opens up, it only has a minimum value. There actually is no maximum value, and then it's the reverse if it's flipped upside down with that. Okay, so we're just going to do one quick example, and then we'll talk a little bit about graphing them individually next. So in this one, this first example down at the bottom, we're just going to take a look at graphing a sketch of this, but specifically finding what the axis of symmetry is and the vertex. So to do that, the first thing we want to do is look at the equation. We see it has 3 terms. It's in standard form. So we're going to focus on the coefficients. So x squared plus 8x plus 15. Notice that the coefficients are going to be 1 and the second coefficient is 8. So we're going to use the formula negative b over 2a, and we're going to see that if we take the opposite of 8 is negative 8, and we take the 2 times 1, which is 2, so that gives us an axis of symmetry that is equal to x equals -4. And we say that it's x equals because it's a vertical line. Now this happens to be the x coordinate of the vertex. So in order to find the vertex, all we need to do is we need to plug in the value into the equation. And so notice that since it's the x-axis or the x coordinate, we're going to plug it in for x, and what we end up with is we end up with a y value of -1. So it turns out the vertex is -4, -1. That's where the value, that's where the vertex or the turning point is going to be. Now since a is positive, we know that it opens up. So when we draw a sketch of this, we can really just draw a sketch and sort of indicate where it is, and we know that it opens up. We know that the axis of symmetry goes through -4, and we know that it's going to be down in that vertex is going to be down in the third quadrant. So that gives us a little bit of an indication on how to do that. Again, use the formula to find the axis of symmetry, and then we can use and go ahead and plug it in to find the vertex.